Let's take a trip in the Wayback Machine. Back in the 80s, we all had personal computers that ran DOS, and we were happy with it. By the time Windows came out, we were ready for a graphical user interface. In the early 90s, when Windows finally became usable, Windows sat on top of DOS, and Windows apps required the Windows runtime environment in order to be able to run. You may not remember this, but apps like Microsoft Word required Windows, but lots of people didn't have Windows installed, so you could, at the time, be running DOS as your normal operating system and just install Windows long enough to run Word and then close it up when you were done and Windows went away again, because people didn't really like Windows back then. Anyway, so Windows apps provide a consistent API for communicating with drivers and devices and so on. In my past life, I spent years writing device drivers for printers and screens for a DOS-based application in assembly language. Well, when Windows came out, my job, as they say, became redundant because Windows provided those services by hosting drivers internally, so I didn't have to write them anymore. So that's 1991. By 2001, we have a very similar situation. The .NET runtime sits on top of Windows, just like Windows sat right on top of DOS. .NET apps require the .NET runtime environment enabled to be able to run. .NET apps provide a consistent API for working with Windows, data structures, data types, and more. So you can think of the .NET runtime as just a Windows on top of Windows that provides more services for applications and developers. You can think of the .NET runtime as an environment that handles data types, memory management, APIs, and much, much more, as you'll see. So why are you here? Why does anyone care about .NET? Well, before .NET, software development required mastery of multiple technologies and authoring tools. You generally had to manually stitch together various programming tools in order to build your applications. For example, if you want to build a website, you had to learn VB scripting or JScript and HTML and some of the pretty ugly tools available for building websites. If you wanted to build database apps, you'd have to learn T-SQL and SQL Server most likely, or some other server application. If you wanted to build business applications, well, most likely Visual Basic would have been your language of choice. If you want to build Office applications, you had to learn VBA and manage to work in a COM-based environment with Office objects using that scripting language. If you wanted to build streamlined graphics applications, most likely you use C++ to do your work. .NET provides remedies for these issues. It provides an object-oriented view of Windows. That is, the .NET framework encapsulates lots of functionality into groups of classes. Application security is built in. You don't have to worry about providing your own authentication and authorization tools. It's all built into the .NET framework. Deploying applications on the .NET framework is easier as well, because all of the .NET application exists in containers called assemblies. And these containers, well, you can deploy them without having to add entries to the registry or worry about installing other bits and pieces. The .NET framework and your assembly is all you really need to run an application for the most part. You don't need to worry about versioning issues. How many times have you built applications and then attempted to deploy a newer version and dealt with all of the issues involved in that? The .NET runtime largely handles those issues without much effort on your part. Assemblies can be digitally signed. Using Authenticode as one of the options, you can see, or users can see, who authored the application. This helps users make intelligent decisions about which applications are safe to install and run. And unless you're using COM, and you can, although we won't cover that in this course, there's no need for registration. You don't need to write things to the Windows registry in order to run your applications. Now you can if you want, but you don't have to work with COM and the registry. In addition, all .NET languages are interoperable. You can write some pieces of your application in VB, others in C# and others in some other language if you want, and they can all communicate with each other. And this leads us to the concept of the .NET Framework architecture. If we stop and take a look at this picture, which I'm guessing you've probably seen before, it's hard to miss in any of the documentation about .NET, what you see at the bottom is Windows and COM+ services, which indicates that all this still sits on top of Windows and the features provided by Windows. Now, I will mention that there are versions of the .NET Framework that are currently running on other platforms. There are initiatives outside Microsoft to cross-port the .NET Framework to Linux, to the Mac, and so on. In this course, we'll be focusing on Microsoft technologies and using Windows and starting there. On top of Windows sits the Common Language Runtime. The Common Language Runtime is a set of services that provide all the features we'll use when running .NET applications. On top of that is the base class library. The base class library is a set of classes that provide all the functionality that you can take advantage of in your .NET applications. Now, within the base class library, we have various groups of classes. This diagram just shows a couple. ADO.NET and XML, for example, is a common way to work with data using the base class library, the .NET Runtime, and so on. Now, we also have various ways to build applications. ASP.NET allows us to build web applications. Windows Forms is the common name for the platform built into the .NET Framework for building Windows or client-side applications. In addition to all the user interface and classes, there is a common language specification which identifies what languages must provide in order to work in the .NET world. This specification is public, so anyone who cared to could write a language that fit in with the rest of these tools. Many vendors have done that. Microsoft ships languages like VB, C++, C#, and JavaScript with Visual Studio, but you can find lots of other languages like Python, COBOL, Fortran, and others that work in the .NET environment and use this same set of services and classes as the languages we'll look at here. Now, all of that is free. You don't need to pay a penny to get all of those tools. If you actually want to be productive, however, you'll want to also find a copy of Visual Studio. It was originally called Visual Studio.NET. Some people still call it that because it is the .NET version of Visual Studio. It's the Common Language Runtime that provides a runtime environment for all your .NET applications. We'll call it the CLR. And the CLR's purpose is to load and run applications that have been compiled to intermediate language, IL. Some people call it MSIL for Microsoft Intermediate Language, but it's just an intermediate language that the compilers create. Every .NET compiler creates IL as its output. We'll look later at how that IL becomes executable code. The CLR manages .NET-based services like memory management, garbage collection, removing things from memory when they're done, exception handling, that is, handling errors in applications. And it's important to notice that this is here at the CLR level, which means that applications have a standard and common way to bubble exceptions from one application or one procedure to another. So it's not up to each individual procedure to handle exceptions. It's handled by the CLR. In addition, obviously, the Common Language Runtime is in charge of loading and running applications. Let's stop and look at how the CLR runs code. The CLR allows you to run both managed and unmanaged code. And what do those words even mean? Unmanaged code is code that runs outside the Common Language Runtime. That is, code that was written before we had the .NET Runtime, like VB6 or native C++ code that were compiled without .NET. Although it's not the Common Language Runtime that loads these things, applications can cause these to be loaded, and they'll still work with the CLR running at the same time. Managed code runs within the CLR and benefits from all the CLR's features, memory management, garbage collection, and so on. Now, as I mentioned, the CLR and its compilers create MSIL on output. They don't create native code, they create IL. At execution time, the just-in-time compiler converts that IL code to native executable, and this little picture diagrams that. If we start with any .NET language, the language compiler at compile time creates MSIL code, as you see in the middle of the diagram. Then at runtime, there's a just-in-time compiler, often called a JIT compiler, that creates executable native code from that MSIL. You might think this is a drawback, but it actually adds some extra benefits. The JIT compiler takes the native processor into account. It creates code optimized for the local environment, if it can. That is, the JIT compiler can make decisions about how to optimize your code at runtime. Therefore, if you were to install your application to a computer, say with a Pentium 3 processor, I know there's some out there still, and then install it on a computer with a Pentium 4 processor or something even better, who knows, the just-in-time compiler could make different runtime decisions about how to compile that code into native executable so it would behave best for each individual computer. Now, it only needs to compile the application once. The compiled bits are cached locally. The performance overhead is very slight, if any. So you really needn't worry about, for most applications, any overhead involved in that first JIT compilation. And it's a far more complicated procedure that I'm showing here. It doesn't JIT the entire application, it only loads the pieces, it compiles the assemblies, and we'll talk more about what an assembly is soon. It only compiles the parts it needs and puts off compiling others until it actually uses them. Remember, the .NET runtime and, included with it, the Common Language Runtime must be installed on client computers in order to run .NET code. Of course, there's a question of how it's going to get there. On some computers, it will already be there. If you're running Windows Server 2003, for example, a version of the .NET runtime is already there. Microsoft Update, for many users, downloads the .NET framework for the user. It's not a small download, and it's not something you should take lightly. You can't install it from a floppy, for example, but what's a floppy anyway at this point? Let's take a moment and look at the BCL, the Base Class Library. This consists of classes that provide base functionality for the .NET framework, and many classes also that make your life as a developer easier. I sort of found that at any point, if there's something I need that I think other people may have needed before me, I don't write it myself. I look in the .NET Framework documentation, and I'm likely to find it there. This is a library of classes that are used by all .NET applications, and you should, as you become a more experienced .NET developer, become more and more aware of what's actually in the .NET Framework Base Class Library that will make your life easier. The Base Class Library contains a large number of classes, and you might be wondering, what is a class? Well, for now, think of a class as just a block of functionality, including properties, that is something that describes this class, methods, that is something that the class can do, an action it can take, and events, that is a way of providing notifications about the class, grouped into namespaces. And a namespace is just a grouping of classes in which every class has a unique name. The Base Class Library's namespaces group classes into common blocks of functionality so that all the classes dealing with file input and output are all in one namespace. All the classes dealing with data management are all in a single namespace. It's just a way of grouping things so you can find them. To get you started, here are some common, or things you'll use often, Base Class Library namespaces. For example, there's the System namespace. This includes all the essential support you'll need for programming, including base types like strings, integers, date, time, Boolean, so on. There's math functions, garbage collection, memory management, and more, all within the System namespace. Every application will use classes from the System namespace. There's no way around it. There's the System.data namespace. Notice that dot. They use the dot as a hierarchical organization tool. everything, for the most part, comes under the system namespace, so you will name it system.something. Now, there's other root namespaces. There is a Microsoft root namespace for things that applications that aren't using Microsoft tools might not use. But for things that are part of the base class library that every .NET application will use, the root namespace is generally system. System.data is a namespace that provides classes for working with data, including SQL Server, OLADB, ODBC, and so on. System.diagnostics provides the classes you need to diagnose, including event logging, performance counters, tracing, and process management. You'll find lots of good tools in the System.diagnostics namespace. System.globalization. Well, that provides fundamental support for globalization. That is, translating applications to work in multiple locales. And it's used throughout the entire .NET framework. So many different methods in the .NET framework use features from System.globalization to be able to provide, well, globalized versions of your applications. There's the System.io namespace, which provides fundamental support for working with, well, the technology is called a stream. And a stream is a class that provides functionality for moving data from one place to another, because that's what input-output's about, right? I/O, System.io. It's about moving data from one place to another. Now, the endpoint of that might be a disk file, so there's plenty of support in here for working with disks, files, folders, and so on. And throughout this course, this namespace gets used a lot because it's a great way to show off examples of other things. We'll look a lot at System.io classes in this course. The System.text namespace includes functionality for working with text encodings. It also includes the string builder class, which shows up in some of our demonstrations. There's System.text.regular expressions, and here you can see that the .NET framework isn't above creating multiple nested namespaces. There's System, System.text, System.text.regular expressions. Well, regular expressions provide a subset or a certain corner of text operations that allow you to provide support for robust parsing and matching of string data. System.web provides design time and runtime support for creating and displaying web applications. If you're using web applications, you'll be living in the System.web namespace. System.windows.forms is the namespace that provides all of the features you'll use when building Windows applications. All the controls, all the forms, all the features of Windows applications live in this namespace. System.xml provides support for reading and writing XML content. And here we've covered about 10 of the hundreds and hundreds of namespaces in the .NET framework. And we've just showed you the names. We haven't looked at any of the classes inside them yet. Throughout this course, we will focus on several different namespaces and the classes within them. Microsoft provides several .NET languages, including Visual Basic, C#, C++, JavaScript, and other vendors provide other languages like Python, Fortran, COBOL, and I don't even know what Python is, but I'm sure you do, and you'll find that you can use it within the .NET runtime environment. How do these languages interoperate? Well, .NET provides the Common Language Specification, which describes how a .NET language should work. In addition, the Common Type System, don't you love those three-letter acronyms, CTS, describes how data types should work together so that you can write code that uses a string and somebody else can write code in a different language that uses a string, and all of us can play along together. In the end, all .NET languages compile to IL, and we'll be looking at some IL to see how it all plays out. We're going to spend some time looking at a .NET application, and to do that, we'll need to think about what an assembly is. An assembly is what you get when you compile managed code. You compile it, you get an assembly. That's what comes out the other side. Theoretically, an assembly can contain multiple modules, although Visual Studio only supports creating a single module assembly. So that's all we'll see in this course. The output is either an exe or a DLL, just like any other environment, and actually these contain compiled IL and information about the assembly. That information is called metadata, and that contains a manifest that describes the assembly, procedures and types it exports, and other assemblies it requires. In a moment, we'll look at a manifest and see what's actually in there. You'll find version, name, culture, and security requirements. There's a list of other files in the assembly and also a cryptographic hash for each file, so the .NET runtime can tell if the file has been modified. There's a list of public types, types that are exposed by this assembly, and a list of external required references, other things this assembly needs in order to run. We'll be looking at ILDASM, that's the IL disassembler, which comes with the .NET framework to examine the contents. In just a moment, we'll take a look at a .NET assembly and see what's actually in there. So what are your options? You can create a large range of applications with .NET. Visual Studio includes templates for these items, among a few others: Windows applications, console applications, and to be honest, we'll be building console applications throughout this course because we don't know what your goal is. We're not sure if you're building Windows apps or web apps, so we'll go with the common ground and we'll build console applications. Because we won't be focusing on building user interfaces in this course, just language features. Console applications seem the safest way to build a common ground. You can build class libraries, libraries of code that other applications need to use. You can build a Windows control library that has a bunch of controls for Windows applications, or the same thing for web applications. You can build a web application. You can also build an XML web service, that is, a programmable object living on the web that someone can retrieve information from or interact with over the web. Well, it's finally come time to build our first .NET application. Using all the information you've seen so far, let's just jump in and give it a try. So you think I'm going to jump right in, but no. Before we use that luxurious development environment, let's try it the hard way. I'd like to see the command line compiler and how it works. So I'll start by going to the command line, CMD, and here let's try running the Visual Basic Compiler, VBC. Oops, it's not there. This will happen to you. The fact is that it is there, it is installed, it's just not available through the normal command prompt. Microsoft, when installing the .NET runtime, didn't want to mess with your path in Windows, so they didn't. Instead, they provided their own command prompt with its own path. To see that, Visual Studio Tools, and there you'll see the Visual Studio command prompt. Okay, once I'm here, I'll change the root folder, doesn't matter where I am, and here I'll type VBC. And look, there it is. That's the output from just getting a list of all of the command line options for the Visual Basic Compiler. Okay, well, I think we're ready to use the Visual Basic Command Line Compiler, and to do that, I'll start Notepad. And within Notepad, I'm going to write my first VB application. Let's just type it, then we'll dissect it. I'll create a new class called Hello World. And within that class, I'm going to type public shared sub main and sub. Notice I like to type the beginning and ends of things at the same time, so I don't forget to type the ending. I'll put a comment in. Display text in the console window and end with system.console.writeline hello world. The obligatory hello world example. You'd think it was part of our contract that we had to do a hello world example before moving on. Okay, I'm going to save this thing. I'm done writing the code. We'll describe the code in detail in just a moment. Let me save it as C:hello world.vb. Normally, code files in Visual Basic end with the extension .vb. Let's go back to our command prompt, and we should find it here. There 'tis. And let's compile it. VBC hello world.vb. And that should, I've never seen such enthusiasm. Look, it compiled. It succeeded. Some notice would be helpful, but they just say, hey, if it didn't fail, we'll say nothing at all. So now we have our executable. There it is, hello world.exe. Not real big. Most of the work's done outside this application in the framework itself. Let's run it. You waiting for something exciting to happen? Here it goes. Boy, it worked. Our first .NET application. How exciting. Applause now. I'm sarcastic because we really didn't do much of anything, but we at least proved that it works. Let's go back to our code and see how it works. First of all, this code declares a class. Every application in the .NET runtime centers around a class, or more than one class. In this case, our class is named Hello World. A class is a container for functionality in the .NET world, and in this case, it contains a single procedure. A procedure is a block of code, and in this case, it's named main. Public means, the public keyword, means that this block of code is accessible from outside this class. So someone outside it could use it. Shared means that the .NET runtime can call this method without having to explicitly create an instance of the class it lives in. Normally when working with a class, you create an instance based on the template defined here. This is just a blueprint, a template for an object in memory. You could create multiple instances of the class at the same time. We'll look at examples of that later on. But because this is shared, the shared keyword indicates that the .NET runtime doesn't have to explicitly create an instance of the class. It will happen automatically when someone attempts to call this main procedure. Sub indicates that the procedure doesn't return a value. This could have been function, and then we'd have to return a value. The main keyword here is just a name for the procedure. By default, every application has a procedure named main, and that's what the .NET runtime looks for to start the application going. Within our main procedure, we have a comment, and you indicate a comment with that apostrophe character. And then we have our line of code that does something. System.console.writeLine hello world. Okay, so what is all that? System is a namespace. It indicates where to look for the functionality we're using. Console is a class within the system namespace. It's one of many classes that provides functionality for your applications. In this case, it provides us with the functionality of interacting with the console. The writeLine method lets us write a line to the console window. And it accepts a lot of different types of values to write. One of the ways it can work is accepting a string parameter. A string is encased in quotes here, and this indicates that what is inside those quotes should be replicated exactly in the output window. Parameters are enclosed within parentheses here. We only have this single parameter, so we only have one item of data inside the parentheses. We have the end sub line of code to indicate the end of the sub and the end class, and that's all there is. Obviously, we'll be looking at examples that are more complicated than this, but that's a start. Now, we're going to write a lot of code in this course, and if we had to refer to the full namespace name for every method we called, it would get kind of old. To avoid typing any more than you have to, the compiler allows you to go to the top of the code file and put in the shortcut. And the shortcut is the imports keyword. The imports keyword, followed by the name of a namespace, allows you to not have to type that namespace name in your code. So this works just the same way. Now that we've imported that namespace system at the top, when the compiler attempts to compile this code, it finds this reference to the console class. Says, I don't know what this console class is. Where's it coming from? It's not in this code file, so where is it? It then looks at the import statements at the top of your file, and at compile time says, Oh, system, I got it. Okay, so the console might be in that system namespace. It goes and looks, finds it there, and now it knows where that console class is coming from. So we've created our application. What's actually inside of it? If we go look back at the command prompt, we have hello world.exe. I'd like to use the IL disassembler to look inside that assembly. Remember, an assembly is just an executable blob of code for the .NET runtime, in this case, an executable. I'm going to type ILDASM, that's our IL disassembler, and send it hello world.exe as a command line parameter. This runs ILDASM, showing the information in our hello world executable. Now, this isn't something you'll do on a day-to-day basis. You don't normally have a need to run the IL disassembler. You may not do it again for months and months. So take this as an exercise in isn't that interesting and file it away. That you can do this if you want. Let's stop and look at the manifest first. The manifest contains information about the different assemblies that this application needs in order to run, and also information about what this assembly exposes to the world. We have an external reference to MS Core Lib. That's the assembly that is the guts of the .NET runtime, and clearly every application needs that. We have a reference to an external assembly named Microsoft.VisualBasic. This provides the Visual Basic functionality, language features that you might use in Visual Basic. Next, we have the system assembly. Well, that's what provided that console class. We've got to have that. Next, we have information about our assembly, hello world, including, its hash algorithm and its version number and all sorts of other stuff you really generally don't need to deal with. But it's here in the manifest, so other applications can find out what's up with your application. There's this block called my, and my is a feature provided by the Visual Basic compiler that makes it easier for Visual Basic developers to work with their code and their environment. We'll talk more about my in a later example. Hello world, that's our class. We can find our main procedure here. Well, that's the disassembled version of our procedure. Not much to it. It says the code size is 11 bytes. We have a stack size, we have text hello world, which we load onto the stack, and then we call this procedure, which takes our string and writes it out to the console window, and so on. And if you wanted to, if you were the type of person that really didn't like getting work done, but really liked sitting at their computer all day and night, you could write this code this way instead of using a high-level language like Visual Basic. Just like at any point, you could write applications using assembly language, another sort of low-level development tool like IL. There are people who write code in IL because they're too pure for Visual Basic or C# or some other language. But the fact is you won't, most likely. You're going to use Visual Basic, and most likely you're not going to use Notepad either. But at least now you've seen the tools and know what's available outside of Visual Studio. You've seen Notepad, you've seen the command line compilers, and you've seen the IL disassembly tool.